everything will be good. Ne?
Yeah.
So if let's say you are given a right angle triangle like this, in most cases, maybe they will give you some statements they want you to complete. You understand?
Yeah.
So this is A, B, C, and we can see by that 90 degrees that this is a right angle triangle. How do we say right angle triangle? By the 90 degrees.
Yeah.
You get that, ne?
Mm-hmm.
So let's say they want you to complete the following statement. But first thing first, I need you to understand how to use the so part tool. Understand?
Yeah.
So this one is for sine, meaning that the sine of, if this is angle theta, the sine of that theta, it will be O for opposite. So what I need you to understand is that if this is your angle, the side that is opposite to that angle, what is that side? It's your opposite. And then this will be your adjacent. Just know that the moment you find this to be opposite, this side, it will be adjacent, meaning your opposite and your adjacent are the one that form a 90 degrees.
Yeah.
So this will be your hypotenuse. You get that, ne? So now, sine is opposite over hypotenuse.
Yeah.
Which is the same as saying this is y over r. You understand? Then we do the same for the cos of theta. The cos of theta, you look at this. A for adjacent. So this will be the adjacent over what? Over h for hypotenuse. So this will be hypotenuse, which is just x over r. And the last one, that is the tan of theta. So tan, O for opposite. So the O comes first, then you divide by A.
Yeah.
You understand? So what you need to understand from this is that the number here is on your numerator. So all those numbers that should come on top. Then the last one, they should be your denominators. These numbers are the ones that you must divide with. These are your denominator.
Yeah.
Do you understand? Okay. So now we are saying that this is opposite over hypotenuse, right?
Yeah.
Opposite over hypotenuse. So this will be opposite, that's y over x.
Yeah.
You are in an exam, they give you a certain statement they want you to complete. Ne? Let's say complete the following statement. Ne?
Yeah.
So let's say you are given the sine of angle C. Ne? They say this is equals to AB over, then they leave a space for you to write an answer. That's the first question. You understand?
Yeah.
For 1 mark. Then the second one, another one for 1 mark, they'll say blah blah blah, and then angle A is equals to, then there'll be AB over BC. Understand?
Yeah.
So let's complete this for 2 marks and see what we can do from this part. Ne? So one thing I need you to look at is that the sine of angle C, which is this angle. Understand?
Yeah.
So sine is opposite over hypotenuse. You have to take your opposite, which is this part. It should be on top. That's your AB. And then you divide by your hypotenuse, which is AC. So the answer for this one is hypotenuse, which is AC. You understand how we got that one? All good. Then now, when you see this, we need to check, is this cos, is this tan, is this sine?
Yeah.
Between these three, we need to choose one that we need to write here. So they say A, the angle that we are using is angle A.
Yeah.
So if we are using A, this is my angle A. Do you understand? So if this is your angle A, what will be your opposite?
Also be BC.
Exactly. This will be your opposite. And then remember, I said the 90 degrees is between opposite and adjacent.
Yeah.
This will be your adjacent. You have your opposite, you have your adjacent. Eh?
Yeah.
So since you have your opposite and adjacent, what's next? You're going to say, okay, this is AB.
Yeah.
You understand? So the AB is your adjacent.
Yeah.
And then the BC is your opposite. Do you understand? Is this working? We said the BC is your opposite, ne?
Yeah.
Your AB is your adjacent.
Yeah. Yeah, you're right.
Which one is adjacent over opposite? Do we have that?
The only thing that's close is the tan, but that's opposite of adjacent.
Okay, so it's AB, which is adjacent over opposite. Wait. I'm trying to. Oh, it's fine. I think where is this coming from? Ne? Let's look for the one that has adjacent and opposite. Which one is adjacent and opposite? Do you have it? No, we don't have.
No, you don't have a.
The one for adjacent and opposite.
So
okay,
there's the tan, but that's opposite of.
Let's just change the question. Maybe there's a mistake here. This should be AC instead, ne?
Yeah.
So that our answer can be AC, that's hypotenuse, ne?
Yeah.
So that our answer will be what? The cos.
Yeah.
So this will be hypotenuse. So it's adjacent over hypotenuse, which the correct answer will be the cos.
Yeah.
So the cos of A is the one that will give us AB over AC. Are you happy with that?
Yeah.
Okay. So the next part of the question that you should expect in trigonometry, they have to do with simplifying. Ne? Okay. Simplifying trig expressions. This laptop is not charging. Oh. Yeah, I'll got now. Okay, so when we simplify trig expressions, when you simplify trig expression, let's say that we need to simplify the value of the sine 60 degrees, right?
Yeah.
And then the sine 60 degrees is multiplied by the tan 30. You understand that?
Yeah.
This is divided by the sec 45. Okay. So now, before we go into this, we need to understand how the reciprocals works. How do we do the reciprocals? You still remember the reciprocals?
Yeah.
I write the reciprocal. So let's quickly write the reciprocal down here. Okay. We call this reciprocals of trig ratio. Okay, so the first one it's 1 over the sine of theta. So where you see 1 over sine theta, we can definitely sub in this to be the cosec theta. You understand? So this will be the cosec theta. And then the second one, it's 1 over the cos of theta. So where we see 1 over the cos theta, we can put the sec theta. And number 3, where you see 1 over the tan theta, we can definitely sub in that as the cot theta.
Yeah.
Okay. So when I work on this, I can definitely simplify this problem. So to work out on this problem, first thing first, I can use before that, let's say this is the sine 60 degrees times the tan 30 over the sec. Sec is reciprocal of cos. So I can write this as 1 over the cos of that 45.
Yeah.
Is that making sense? So when we solve this, remember, I'm going to treat these two equations. Let me do it like this. You see the equation on top. This is my equation on top. I need to separate that equation with this equation. I can separate the two equations. I'm not sure if you understand what I'm saying. So we write them separately like this. So the first one, the one on top, is sine of 60 times the tan 30. So you can just take everything and say this is over 1. This is divided by what? 1 over the cos 45. So the aim is for you to change that division into multiplication. You understand?
Yeah.
So when you change the division into multiplication, this will be multiplying by the reciprocal, which is the cos 45 degrees over 1. Then you can definitely, maybe they said without using a calculator, so you need to show all your steps. What is sine 60 equals to? You have your calculator?
Oh, yeah.
So when they say without using a calculator, they will just want you to show all the workings.
It's the square root of 3 over 2.
Okay, so this will be the root 3 over 2 multiplied by the tan 30.
Which is square root of 3 over 3.
Okay, so if you have, listen, if the number inside the square root is the same as your denominator, this is tan 30, right? You need to rationalize the numerator. Can you see the 3?
Yeah.
It's inside the square root. It's the same as what you have on your denominator. You rationalize, you multiply top and bottom by that root 3. Understand?
Yeah.
So you're going to multiply the top and bottom. This is what we call rationalizing the numerator. So I can definitely multiply the top part and the bottom part by root 3. Then this times that will give us 3 over this times that will give us 3 root 3. The 3 cancels, the final answer is 1 over root 3. So the answer that you should substitute here, 1 over root 3. If you put root 3 over 3, that's how they say that you use the calculator.
Yeah.
This is multiplied by the cos 45. What is cos 45 equals to?
Equals to wait, it's square root of 2 over 2.
Same thing, you understand?
Yeah.
So if you have the cos of 45, it leaves you with root 2, so it's going to be root 2 over 2. We need to rationalize that,
Yeah.
Okay, it's root 2
over 2.
Okay, so multiply top and bottom by root 2. The 2, when you multiply them, this gives us 2 over. Then you multiply the 2, this will be 2 root 2. The 2 cancel, the final answer is just 1 over root 2.
Yeah.
So we're going to substitute this as 1 over root 2. So you're going to multiply this 3 denominators. So it's Root 3 times 1, that is just root 3, over 2 times root 3 times root 2. Remember, if I say root 2, what is this? If I say root 3 times root 2, this is the same as 2 times 3, which is 6. So this will be 2 times root 6.
Yeah.
You understand? Maybe we can definitely simplify this further like this and say, I'm going to take, remember, this is times 1, right?
Yeah.
Let's take the 1 over 2 aside, and then let's put these two guys inside 1 square root. Because if I have A over B, this is the same as A over B, everything squared.
Yeah.
So that's what I applied. So this will definitely be 1 over 2 times 1 over 2. The root 1 over 2, which is just, I'm trying by all means not to use a calculator, 1 over 2 with 2. That should be your final answer.
Yeah.
You get it, ne?
It's for the fractions. If the number in the root is the same as the numerator, if it's the same as the denominator, then you rationalize.
You rationalize. You get that part,
Yeah.
ne? I think that part is also like very, very important, ne? All good.
Yeah.
Okay. So this is how you simplify trig ratios. You definitely have to understand how to do the simplification, ne?
Yeah.
So the next one that we're going to focus on, it has to do with the diagram. Let's say that you are given a certain diagram. In the diagram, let's say that you have P, and the coordinates of P is -5 and 12. And then they say this is a point on a Cartesian plane. And we are given theta and R angle OP that's equals to theta. The diagram looks like this. So you need to know how to answer questions based on a diagram. P is -5 and 12, ne?
Yeah.
And then this angle here, that's theta, because we have a point here, that's point R, and this is O. That's why they said ORP is theta. So now we need to answer the following questions, né?
Yeah.
From this diagram. The first one, determine, they want you to determine the value of number 1, the cos of theta. Number 2, the cosec squared theta plus 1. You understand?
Yeah.
Both of these questions is 3 marks, né? How are we going to work with this one? You know, one thing that you can do first, né? You analyze the diagram, make sure that inside your diagram, you know everything that you have, né?
Yeah.
This is your x value, this is your y value. So if I draw my right angle, this is 90, right? So my y is 12. That is y,
Yeah.
right? My x is -5. There's missing r.
Yeah.
We need to find that. How can we find r?
Theorem of Pythagoras.
Exactly. So this will be r squared is equal to x squared plus y squared. Let's just do the substitutions. R squared is where there's x. We're going to put -5. There's a squared plus where there's y. We put 12. Please help me with the calculator. Tell me what is 25 plus 124. Or just say minus in 5 squared and then 12 squared. What do you get?
169.
You got
169.
169, eh?
Yeah.
So this is 169. We're gonna square both sides. I think it's 13, eh? Therefore, R is always positive.
Yeah. Yeah, it's negative for positive 13.
Okay, negative. Therefore, we conclude R is always positive. So the answer is just 13, right?
Mhm.
So now that you have R, your R is 13. Now you can start answering the questions. Okay.
Yeah.
So when we do like answering the question part, you know what you need to do.
Yeah.
Look at this point here. This is what you have, and they want the cos of theta. So you're gonna say for one, you use the shortcut tool. Okay.
Yeah.
You use the shortcut tool. So when you use the shortcut tool, uh, you look at cos, which is adjacent. The cos of theta is what? Adjacent all over hypotenuse, right?
Yeah.
And tell me, what is your adjacent? If in
Adjacent
this
is
quadrant, in this
uh,
triangle, what is your adjacent?
in the in the
Right. Remember, this is my
yeah.
angle. What is your adjacent?
uh, negative 5.
Negative 5. So the answer will be minus 5 over, and then what is your hypotenuse?
13.
30. Therefore, that's the answer. Which makes sense. Cos in second quadrant is negative. Therefore, the final answer is cos of theta is just minus 5 over 30.
Yeah.
And that's it. You get it now?
Mhm.
Okay. So let's say we need the cos. If you remember, we talked about the inverses, right?
Mhm.
We said that the cosec is the reciprocal of sine. Eh?
Yeah.
So 1 over sine, where there's cosec, we can substitute that as 1 over sine. But I need you, this is how I want you to solve this problem, okay?
Yeah.
So first thing first, we are looking for the cosec squared theta plus 1.
Hmm.
We know that 1 over the sine of theta is the reciprocal of cosec, ne?
Yeah.
Cosec theta. First thing first, you know what you need to do? Find sine theta first. Using the diagram, sine theta, it's opposite over hypotenuse. So the sine of theta is opposite over hypotenuse. Then you go on your diagram, you check what your opposite. Remember, if this is the angle, this is my opposite, this is my adjacent, right?
Yeah.
So your opposite is 12 over hypotenuse, which is 13.
Yeah.
So sine of theta is 12 over 13. Listen, since sine is the reciprocal, when you substitute on cos, you do vice versa. This becomes a denominator, this becomes a numerator. So for cosec, you just change sign. So you're going to substitute 13 over 12 squared plus 1.
Yeah.
You get it,
Yeah.
ne? You get it?
Yeah, I get it.
Or you can definitely write it first to show the examiner that this is 1 over the sine of theta, everything squared plus 1. You understand?
Yeah.
And then when you work it out, this is 1 over the sine of theta is 13 over 12.
Yeah.
Everything squared plus 1. When you solve this, it should give you that, which is just 13 over 12 squared plus 1. So 13 squared, that's 169, eh?
Yeah.
And then what is 12 squared? 144, eh?
Yeah. 144.
Then add 1. Can you tell me what is the answer when you add the 2? What is that equals to?
It's 313 over 144.
Okay, in decimal form,
In decimal form, it's 2.17.
2.17. That's the answer.
Yeah.
All good, ne?
Mm-hmm.
Do you understand how we solve these two questions?
Yeah.
So this question, they have to do with drawing the diagram, ne?
Yeah.
Now, let's move to where you'll have to solve for theta. Okay. Correct to one decimal place, ne? Where x is less than 90 degrees, greater or equals to 0 degrees, ne?
Yeah.
So let's say the first one, number 2, number 3. The first one, let's say it's 5. The cos x is 3. Number 2, the tan 2x. And then this is 1.19. And then for the sec x minus 3, that's 5. Okay, we'll try and work on these questions now.
Yeah.
Okay, let me. So with the first one, this is just gonna be an easy one. So to solve for this, for the first one, number 1, ne?
Yeah.
We're gonna say 5 the cos x. This is equal to 3.
Yeah.
The aim is to make sure that you eliminate this guy here. 5 the cos x. You need to put it on one side.
Yeah.
I'm not sure if this makes sense.
No.
You get it
Yeah.
now? Okay, so you need to make it, put it on one side. Next. So divide both sides by that 5. Divide both sides by that 5.
Yeah.
Therefore, this gives us the cos x to be 3 over 5. You understand that? We need to solve for x. So x will be the cos inverse. Then you say 3 over 5. You know how to punch that on the calculator, right?
Yeah. It's the cos inverse 3 over 5.
Yes, that's 3 over 5.
Yeah. It's,
and what do you get?
53.13.
53.13. That's very good. So x is just 53.13 degrees. That's the answer. You're done. You move to number 2. So on this one, where you have the tan 2x, this is equals to 1.19.
Yeah.
Okay. So you do the same. We need to isolate the 2x first.
Yeah.
So you're gonna say 2x is equals to dividing both sides by tan give us the tan inverse of that value 1.19.
Yeah.
So you go to your calculator, you say the tan inverse of that 1.19. Shift tan inverse of 1.19, then equals to 49.96 if we round it off. 49.96, but they said correct to one decimal place, so this should be 5.53.13. Let's quickly fix this one. Round this to one decimal place, this will be x is just 53.1. And then for this one, this is 2x, it's equals to, we got, what was the answer? 49.95. So we set 96, 49.96. Then divide that answer by 2. To make x subject of the formula, I'm going to divide this by 2, which gives me 24 point. If we round this off, it's going to be 25.0, ne?
Yeah.
25.0. So to one decimal place, divide both sides by 2, divide by 2. Therefore, this gives us x to be 25.0. This is easy, ne?
Yeah.
Okay. Let's work on the last question, number 3. I'm not sure. Do you want to try number 3 or should we work on it together?
See if I can't try number 3.
You want to work it out
Yeah.
first? Okay, it's fine. You can work on it. Tell me what you get. So let's move and see if we get the same. Then we'll take it from your partner.
Okay.
Okay. So on this number 3, remember that when you are given they say this is 4, the sec x minus 3, and this is equated to 5.
Yeah.
So on this one, what you need to do is to isolate the sec x first. So the 3 comes this side, it becomes positive. So this will be 4. The sec x is equals to 3 plus 5, that's 8.
Yeah.
Divide both sides by 4, by 4. Therefore, this will be the sec x, which is 4 goes into 8 2 times.
Yeah.
Remember, sec is the reciprocal of what? Sec is the reciprocal of
Cos.
yes. So where the sec, we put 1 over cos. So this tells you that I can definitely change the sec. Since you are saying that sec x is reciprocal of what? 1 over cos, right? So I mean sec x. So this tells you that I can change the 2 and say this is 1 over 2. And then instead of saying sec, I can say the cos x. You saw what I did?
Yeah.
Remember, if I have 2, reciprocal of sec is cos. So sec changes to cos, right?
Yeah.
And then this 2, remember the 2, it's over 1. It's going to
so
change and
just
becomes
switch it.
1 over 2. So now, when you have this, you are supposed to change this and write it as the cos is 1 over 2. Then you start wiki.
Yeah.
So x is the cos inverse of that 1 over 2. What do you get? What is that equal to?
It's 60.
You got 60 degrees, no?
Yeah.
60. Okay. And that's it for this one, because I want us to move to the last part, then we'll move to this part of your, what is this? We'll start with Euclidean geometry.
Yeah.
We'll do Euclidean. Let's just work on the last part that I want you to understand. Let us quickly go back to this part. So if you still remember, we had a right angle triangle, but some of the things that we forgot to mention on that part. So in this right angle triangle, this is 90, this is B, C, and then A. I'm gonna call this small c, this small b, and this small a.
Yeah.
So from this, let's say that this A, it's given the side is 16.5. Okay, centimeter. This angle is 16 degrees, and then let's calculate. Let's say we need to calculate B first, right? So to calculate B, we can use, look at this. This is what you should do. You want to calculate B, right? Which is this side. You get it?
Yeah.
And then what do you have? You have this side. Okay?
Yeah.
So this is your adjacent. Okay? This is your hypotenuse. And then this is the angle which make that side to be your opposite.
Yeah.
Okay. So now, what you're going to do, you check according to cartoon. From this, we can see that I have hypotenuse. Okay, I'm looking for this, and I have that.
Yeah.
Hypotenuse and adjacent. You're gonna choose the one that has hypotenuse and adjacent, which is cos. So to solve for that length of B, we use the cos of angle C, which is adjacent over hypotenuse.
Yeah.
Then you substitute the cos angle C is 16, right?
Mm-hmm.
Equate this to adjacent, which is 16.5, right?
Yeah.
Remember this, it's BC, your adjacent over AC.
Mm-hmm.
So divide this by AC. AC is what you are looking for. Okay.
Yeah.
So now, first thing first, you can definitely get rid of the fraction by multiplying this side by AC. What you do on the left hand side, you also do on the right hand side.
Yeah.
So these two cancels, right? Therefore, this gives you 16.5, which is equals to AC, the cos of 16 degrees. You understand?
Yeah.
Therefore, we are looking for AC. So you can divide both sides by that cos 16, divide the other side by the cos 16 degrees. And then this will give us AC. Since the two cancels, AC will be 16.5 over the cos 16. Therefore, what is your AC when you pass that on the calculator? What do you get?
The whole 16.5 over.
Yes. Over the cos 16. We're gonna take this guy here, put it inside the calculator.
Yeah.
What
I got
what's your answer?
I got 17.1. Yeah. That's got a
When we round it
17.1.
off, it's 17.2.
Yeah.
To one decimal place, right? Okay. So let's say they want you to find angle A. What are you going to do? Find
the
angle A.
Yeah.
Remember, this is angle A, right?
Yeah.
I have this angle, I have this angle. Sum of angles in a triangle end up to what? 180.
Yeah.
When we add angle A with angle B with angle C, we should get our answer as 180.
Yeah.
Then the reason will be sum
of
angles in a triangle.
Yeah.
So angle A, it's what you are looking for, right?
Mm-hmm.
You add angle B, which is 90. Then you add 16, which is angle C. Then this is 180.
Yeah.
We're gonna find the sum of these two angles, which is 106.
Mm-hmm.
A plus 106 degrees, it's 180. And then the 106 comes this side. So angle A is 180, you minus 106.
Yeah.
That's 74, ne? That's angle A.
Yeah.
Okay, so now let's look at Euclidean geometry. Okay, so on Euclidean geometry, there are some of geometric facts that you need to understand.
Mm-hmm.
So the first one is what we call the angle around the point. You still remember that one?
Yeah.
The angle around the point. So the first one has to do with this one. If this is, let's say this is A, this is O, this is B, ne?
Yeah.
So the angle around the point, like this, they should give us what? 306. You understand? Yeah. Okay. So now, if I have a certain point that has multiple angles from that point, multiple angles.
Yeah.
This is A, this is B, this is C, this is D. So if I add this angles A plus angle B plus angle C plus angle D, they should give me what?
So give 360.
So the reason will be angles around the point. You understand?
Yeah.
So this one is revolutionary angle. Angles. You understand that part, ne?
Yeah.
Okay. So another fact that you need to understand is angles around a straight line, ne? So they go like this. Maybe this is A, B, C. So when I add all these angles, when I add all these angles like this, all these angles, they should give us 180 degrees.
Yeah.
So angle A plus angle B plus angle C, they should give us 180. Reason angles on
A
a
straight line.
straight line. Right. Another one, it has to do with vertical opposite angles are equal. Ne?
Yeah.
So if this is A, this is B, and then CD. This angle, it will be equal to that angle, and this angle will be equal to that angle. Vertical opposite angles are equal.
Yeah.
So if this is maybe center O, we call this 1, this is 2, this is 3, this is 4. So angle O1 will be equals to angle O2. Vertical
Opposite angle.
angles are equal. So angle O3 will be equals to angle O4. Is that making sense?
Yeah.
Right. So now, when you have maybe two lines that are parallel, you're gonna have what we call the fan weight. No?
Yeah.
Do you know the fan weight?
Yeah.
Uh,
Yeah.
we're gonna have the fan weight like okay. So this is the fan weight. Like this, né?
Yeah.
Okay. So when two lines are parallel, first thing first, let's indicate those parallel lines. This line here, it should be parallel to that one. So this line and that line are parallel. So when you have parallel lines, you will have what we call corresponding angles are equal. Okay.
Yeah.
So this one, we call them corresponding
Angles.
So this will be corresponding angles.
Yeah.
So corresponding angles are equal, meaning that if this is angle A, this is angle B. So angle A and angle B are equal. Reason corresponding angles equal. You happy with that one? So the next one, it has to do with co-interior. Ne?
Yeah.
This line here is the one that should be parallel to that line. So these two lines are parallel, and this is your x, this is your y.
Yeah.
So this tells you that if I take x and then I add it with angle y, they should give me 180. So we call them the co-interior angles. Next,
Yeah.
Co-interior angles are equal. You get it now?
Yeah.
And then let's just look at this one, the last one. On the last one, this line is the one that should be parallel to that line.
Yeah.
So this is parallel to that. And if this is A and this is B, so this angle should be equal to that angle. So angle A and angle B are equal, and we're gonna call this one alternating angles. Ne? Alternate angles are equal. Okay, I'll just try and let's start with E2. When I look for angle E2, I'll first say angle E2 is equals to, look at this, angle E1 and E2, they give us a 90 degrees. I mean a 180, see? So if E1 is 120, E2 will be 180 minus 120. You understand?
Yeah.
And raising angles on a straight line.
Yeah.
Okay. So now, if this is the case, angle E2, it will be 60 degrees. Are you happy with that one?
Yeah.
Now, if E2 is 60, therefore, you can definitely say angle E4, it will be equals to angle E2. Because these two angles here, they give us something like vertical opposite angles. Ne?
Yeah.
This angle here, it's equal to that. So the reason for this one will be vertical opposite angles. So this will be vertical opposite angles are equal. Is that making sense?
Yeah.
Okay. So then, therefore, same applies to E1 is the same as E3. So this is 120, this is 60. Yeah? No, E2 is 60. So this will be 60, right?
Yeah.
This is 120. Same reason as that one. All happy, ne?
Yeah.
So now we're gonna look for F, ne? If this angle is 120 degrees, this is corresponding angles. You understand?
Yeah.
So angle F3, did you get F3 to be 120?
Yeah.
120 degrees corresponding angles are equal.
Yeah.
So now we know that we can use angles in a straight line to find F2. Ne? F2 will be 60 angles in a straight line.
Yeah.
Straight line, right? And then we can definitely use, there are a lot of reasons that we can use to find F1 and F4. Are you happy with that?
Yeah.
All good, man. Do you understand the midpoint theorem?
I think